Okay, good morning. So let us see how is it going for you. So do you remember we are supposed to prove this formula for D. I took a photo yesterday. We are supposed to show that this is 2v node squared cosine alpha plus beta multiplied by sine beta divided by G cosine squared alpha. Am I right? It's not very visible in my photo. Yes. This is the question mark, but we were able to manage to reach to this formula for D, which was 10 alpha minus 10 alpha plus beta, and then divided by minus G cosine alpha divided by 2v node squared cosine squared alpha plus beta. Yes, am I right? So this is what we got so far, but that is the goal in the problem. So we want to reach to that. Okay, could you manage to do that?
Not all the way.
Okay, so let us think about this together. Okay, first of all, if I want to simplify that, I really don't like this minus sign, so I will take this minus sign away and I replace these two. Okay, so then I don't need to be worried about the minus sign. But of course, then I have something in this denominator. This denominator, I hope that you agree with me, this will go into the numerator, yes? So let us do these two together. So first of all, I interchange these two, get rid of this minus sign. Yes? And this is supposed to go to the numerator. So I will let me write it like this, 2v node squared, and then I have cosine squared alpha plus beta, and then I have G cosine alpha left in the denominator. So there are good signs actually that we are in the right track. First of all, you see that I have 2v node squared, I have 2v node squared, and I have the G cosine squared alpha. So far I have G cosine alpha. But it is not that bad, yes? Let us see how it goes. I don't know, do you have any suggestions for me? This is for sure we have to get rid of tangents. Yes, because we do not have any tangents involved. And if I want to get rid of tangents, probably there is only one way to do it, yes? Write it as sine and cosine, yes? So what we can do, so I mean that we want to think naturally. I haven't done that before, but this is the way that I usually think. So here, I would say that this becomes sine alpha plus beta over cosine. It seems complicated, but it is not actually. Minus sine alpha. So that's probably the only reason. The mathematics is involved. So they consider it as a level 1 problem, level A problem in the university text. Yes. So you have to know what to do with mathematics there. And then I have 2v node squared. Then I have cosine squared alpha plus beta. Okay. And then divided by G cosine alpha. Okay, so now what is your suggestion?
You're multiplying one of the cosine plus alpha plus beta.
Multiply everything by this?
No, one of the outside cosine alpha plus beta inside. That's what I did.
Okay, I understand what I mean. Yeah, that's a good idea. So you mean that take one of them and multiply it here,
and then
this I would get rid of this, then I'm left with sine alpha plus beta and here.
Yep.
Okay. And then, yeah, it works, I think. But I was thinking in a different way. So let me follow my, okay, so what I wanted to say, I wanted to take the common denominator here because I can see what is happening. Yes? So if I take the common denominator here, you might think that this becomes complicated, but actually it becomes simpler. Can you see how? So let me take the common denominator to see what is going on. So here, if you don't mind, let me write this first. 2v node squared cosine squared alpha. Of course, I could do what actually Oleg mentioned and then take the common denominator. That will also work. But let me consider this one. So then the common denominator is the product of those cosines, cosine alpha plus beta times cosine alpha, yes? And then this common denominator with respect to this as extra factor cosine alpha that I have to multiply here. This becomes sine alpha plus, sine alpha plus beta times cosine alpha, and then minus sine alpha times cosine alpha plus beta. Yes? So it seems complicated, but I don't know. Do you see the pattern now? So this becomes g cosine alpha. First of all, tell me, are you happy with what I have done? Is it clear? Yes? So I have taken the common denominator between these two, then this goes here, this goes there, the common denominator is still there. Yes? But it's simple now. Can you see why?
It's an angle plus an angle. On the sine angle plus an angle.
Yes. So that pattern, so you might think you have to expand this. Yes, but if you look here, do you remember sine? So this is why sometimes it is good to have something in your memory. Otherwise, if this pattern is not clear for you, is not familiar for you, then you probably will not go and refer to the formulas, yes? So that's not a good idea to use this formula for the addition for here, because then it becomes really complicated, yes? But look, sine u plus v, so sine u minus v in this case, is the sine of the first one, cosine of the second one, minus sine of the second one, cosine of the first one. Now let me give the role of u to this and give the role of v to this. So this is red sine u cosine v, and then this becomes sine v cosine u. Agrees? So is that understandable? So that is actually the right hand side of this subtraction formula. So what can I do? First of all, I would write this one of them is cancelled with this one. Yes? And then this cosine alpha will go into the denominator. Multiplied by another cosine alpha will give me exactly what I need. Yes? So this becomes g cosine squared alpha. And then this becomes 2v node squared cosine alpha plus beta. So I took care of that one. I multiplied this one in the denominator. And then what can I write for this whole combination? I can write sine of u minus v. But what is u is alpha plus beta. What is v is alpha. Yes? And then alpha and alpha go away, and then I will get this one. And I am done. Yes? So this becomes 2v node squared cosine alpha plus beta sine beta divided by g cosine squared alpha. So finally we succeeded actually to get that. And then if you see, mathematics was a little bit more involved. Getting the physical idea was not hard. But if you change, any questions so far? But if you change the coordinate system, it also teaches you some physics. So let us just draw this here again. So here we had this scenario. Yes, so this was alpha, and for example, this one was V node. And then this one is beta. And then we have this, yes? Okay, so if you remember, I told you that this time, try to take this one, let us take this one, the new x-axis. For differentiating between x-axes, let me denote this by capital X this time. And then take this perpendicular line to be the new y-axis. Now I want you to solve this problem in the new coordinate system. So the physics doesn't care about how we choose the coordinate system. Physics is not changed. Still I have the same inclined line, and what is this? And then I have this. Then I have this projectile shooting it, and then still I want to calculate this d. Okay, so let us see if the physics is changed. I hope that you agree with me. Physics is not changed at all. Why? Why physics is not changed? Because still I have to write the Newton's second law to solve the problem. Let us start from scratch again. And this is a vector. A vector does not depend how you choose your coordinate system, but the component of the vector depends highly on the choice of the coordinate system. Yes. For example, if this is the x-axis and this is a vector, the y component is 0. But if I rotate, yes, so if I rotate the coordinate system, then the y-axis will be here, and the shadow is not 0 anymore. Is that understandable? So the components are highly dependent of my choice, but the vector itself is independent of my choice of the coordinate system. Okay, so what does it mean here? This time, this is my position of my particle at some instant of time. To differentiate it here, so let me denote it by capital R instead of little r. But everything is more or less the same, okay? So here I have this force of gravity here acting, so it is m and vector g, yes? Still it is in this direction. By changing the coordinate system, this does not change because it is towards the center of the earth, yes? So that would be this. Okay, if I want to continue and solve the problem in this new coordinate system, what should I do? So the total force is still that one if I don't consider the air drag. So what will happen? This means that I have to write mg, and this is equal to ma. So you see, what is left after cancellation, if you refer to your notes, you get a is equal to g. Do you remember? That was exactly the physics equation we got with the previous coordinate system. So that's why I'm saying physics is not changed. This is a physics equation. It is not sensitive to my coordinate system. If exactly the same form, if you go back and see what we did before. But what is the problem here now? This a, this is the acceleration. It is the second derivative of this vector. Yes, of course I haven't talked about derivatives of vectors, but let us consider component-wise. So if I ask you what is r, r has two components, x component, which I show it with capital X, and y component, yes? So this here, a, is the second derivative of that, so it becomes the second derivative of x with respect to time. Yes, the second derivative of y. And now I equate this one with that one. What will happen? This becomes x double prime, y double prime is equal to vector g. Now this is the interesting part. So what is vector g now? What are the components of vector g? Do you remember what were the components of vector g before? When I took this coordinate system, it was 0 because this is perpendicular to the x-axis, and if you remember, it was minus g in the previous case. Now, can you tell me what will happen in this new case? So let me just draw a picture here for you. So here we have this inclination here, alpha, and then this is your new x-axis, this is your y-axis, and it doesn't matter where, the acceleration always is perpendicular to the horizontal. Okay, but now you want to find the components of this vector in the new coordinate system. So what are the components? Can you tell me what is the x component? If you want to, you can sit down and then tilt your head like that. Yes, this would be easier. Yes. I already told you that the length is g. G is norm of g. So what is that? Let me make it more clear here. So what are the shadows? So now you need to shed light from this side. Yes. So if you want to see what are the components, you take this point and draw a line parallel to the y-axis. Yes. And then draw a line parallel to the x-axis. Yes. And then what happens? This one is the shadow on the new y-axis. Yes. Is that understandable or not? So this blue one is the component of this black vector along the new y direction. Is that right or not? And then this vector, yes, this vector is the component of this along the new x direction. Is that right? But now can you guess what this angle is?
Alpha.
It's alpha. Yes, is that right? Everyone knows, so this probably should be familiar for you from physics. Okay, now what is the length? What is this one? First of all, is this component positive or negative? This is your y direction, and this is pointing in the opposite one. So that's negative. But what is the length? The length is the length of this vector, which I told you is g, and then multiplied by cosine alpha. Yes? So this becomes g cosine alpha. And what happens here? This becomes g sine alpha. So these are the components. But this is the length. So these are the lengths. But the component-wise, this is negative. This is also negative because it's also pointing in the other direction. So what you need to write is the x component is minus g sine alpha minus g cosine alpha. So is that understandable? Yes? Okay, let me give you time to think a little bit. So you see in this course we learned about vectors. Yes, this vector, if I want to find the x and y components, it means that I need to look at the shadow of that vector along the x and y coordinates. So I hope that you agree these are the shadows, yes? And you need to consider the direction as well, because they are pointing against these two, so I should write them with negative signs. So is that understandable? Now compare it with the previous scenario. In the previous scenario, on the x direction, the acceleration was 0. Yes? But on the y direction, the acceleration was a constant number minus g. So it means that on the horizontal, the shadow of the particle moves uniformly. But on the y direction, it is accelerated. But now if I change the perspective, both of them now are accelerated. Is that clear? So it means that if you stand here, and then look the shadow of your particle on this and that, both of them are accelerated. Yes? So this means that this is the difference. Is it clear? Yes or no? Okay. But now, if you don't mind, let us try not to solve everything from scratch. The point is that, by the way, is this acceleration constant or not? Because you already know from physics lessons, if the acceleration is a constant, you already have all the formulas you need. So you don't need to start. Yesterday, I wanted you to see that if I start from Newton's second law, I will be able to derive the formulas that you usually use. Okay? But we already did that, so let us not do everything from scratch this time. So, on the x direction, this is my acceleration. Is this acceleration constant or not? Because the formulas you have studied in physics are for the case that acceleration is constant. Yes? The formula 1 over 2at squared, whatever it is, coming after that, that is only for the case that the acceleration is constant. Yes? So here, is the acceleration constant? G is the constant number, which nature dictates us, and then alpha is its alpha, that doesn't change. So this is constant, that is also a constant. So it means that I am facing two motions, one along the x direction, one along the y direction, but in both cases I have constant accelerations. Yes? Now can you tell me, so do you remember the formula is this? If I have a constant motion in general, so you can say that the x, for example, if you are looking along the x direction, this is 1 over 2 your constant acceleration times t squared plus the velocity, initial velocity along that particular direction times t. And of course plus the initial position. Here I don't need to be worried about the initial position, but because still I start from 0. So if you don't mind, let us just keep it in mind. Okay, that is the formula that you have in physics for constant acceleration. Yes? Here I have two problems. One for capital X, one for capital Y. So what can I write for capital X? Can you tell me? By looking on the board, yes? So capital X is equal to, it should be 1/2, yes? And then what should I write instead of A here? The acceleration along the capital X. It's minus g sine alpha, yes? So I put minus sign here, g sine alpha, and then I put t squared. Yes? And now, can you tell me what should I write for v node in this case? V node in this case is the initial velocity along this direction. What is that?
Minus the sine of x.
No, be careful. I have V node there.
Oh.
Do you remember what was V node for the x direction, if x direction is this? Do you remember? So what did you do? You multiplied this by cosine of an angle. Yes, what angle was that? In the previous case, yesterday.
Alpha plus beta.
Cosine alpha plus beta. Yes, do you remember that? Because you wanted to project it along this direction. But now, you just want to project it along this direction. Yes, so which angle is involved?
Only beta.
Only beta. So then it becomes what? Plus V node. Of course, I hope that you agree that when I project it, it points to the positive direction. So I don't need to put negative. And then it becomes V node cosine of beta only. Yes? And then times t. This is the equation for x. Yes? Is that clear? So this formula gives you capital X. So what is capital X? For example, if the particle is here, oh, by the way, that's also good to ask. if the particle is here and I want to find the capital X by drawing a line, where is capital X for this particle? So where is little x for this particle? I hope that you agree. This is the little x. Where is the capital X? So the only difference, you shouldn't get confused. This is your coordinate system. We usually draw the coordinate system horizontally and vertically. That's the only difference. So you need to understand the meaning of the coordinate. If I want to find x and y coordinates, I draw perpendicular lines to the axes, and then I get this one, the little x. From here to here is the little x, yes? But now can you tell me, if I want to draw a line to understand what is the capital X for this particle, what should I do? Yes, exactly. So you draw this perpendicular line.
Yeah.
And this is the capital X coordinate for that particle. And this is the capital Y coordinate of that particle. Yes? So whatever it is, this is its formula. Is that understandable? Okay. So you are changing your perspective. It's actually teaching you a lot of things in physics, I think. So now, okay, can you tell me what should I write for capital Y if I want to write an equation for capital Y? Y, you see, the acceleration along the y-axis is also a constant. So I can use the constant acceleration formula in physics to write the equation. So what happens? Instead of this acceleration, I put minus g cosine alpha, so it becomes minus 1 over 2 g cosine alpha times t squared, and then plus what? Can you tell me what should I write instead of this?
Initial velocity sine beta.
V naught times sine beta, and then times time. Yes, is that right? Okay, now I have the equations here, and don't forget, I want to find what? I want to find this length. Yes? Okay, can you tell me what to do? So, this length is this point and that point are the intersection points of my trajectory with the new x-axis. Yes? So what I need to do, I need to put capital Y equals to 0. Understandable? Because if I put Y equals to 0, it gives me times at which capital Y is 0. Yes or no? So if I put Y equals to 0, it means that what is the meaning? What I'm doing by putting this 0? I am asking for the times or time at which the y coordinate becomes 0. Of course, it is clear when I start, the capital Y coordinate is 0, so it's not surprising that one answer should be t equals to 0. But there is another answer which will represents the time at which the particle hits here. Yes? So what can I do? I put y equals to 0. This means that I have to put this equal to 0. But there is t in common, so let me factor it out. Then from here, v naught sine beta is left. And from this one, minus a half g cosine alpha times t is left. And then I put it equal to 0. Of course, we already knew that t0 is one answer, so that's not interesting for us, even though it's true. Another t is solving this equation. But don't let these things distract you. This is just a constant number, and that's a constant number you want to make t alone. So you move this to the other side and then divide by this. So what happens? So this becomes 2v naught sine beta divided by g cosine alpha. Yes? So I move this to the other side and I divide by this expression. 2 in the denominator will go here and I will get this. So what is this time? This is exactly the time at which the particle hits here. Okay, now can you tell me what to do to finish the problem? what I am interested now, what is D in this new setup? Yeah, say something. What is D in this new setup? D is lying on this line, which is on the x-axis. Yes? So what should I write? What is D here?
So the x formula and you add in the time.
Exactly. Exactly. So that D is the x coordinate, yes, at this particular time. Is that understandable? So it means that if I go here and replace t with that value, I will get D. Okay? So let me just do this. I have minus 1 over 2 g sine alpha multiplied by t squared, which is 4v node squared sine squared beta, divided by g squared cosine squared alpha. And then I go here plus v node, and then I have cosine beta, and then I multiply it by that t again, so this 2v node sine beta divided by g cosine alpha. Yes? So that's the formula. And let us simplify it mathematically, because that's a reasonable formula. It's expressed in terms of my parameters that I know about them, alpha, beta, and v node. Yes? So now let us solve the problem. Let us see what can we do here. First of all, let us simplify as much as we can in our head, yes? Look here, what I need is g cosine squared alpha. First of all, let me just do it here. This g, I clean it with one of these g's, yes? And then what I do, I clean this 2, yes? And I write this 2. Yes, understandable? And then this v node and that 2v node gives me 2v node squared, 2v node squared, so I can factor 2v node squared out. Yes? So I've already taken care of this part, I have taken care of that part and that part. Agree? And then I take g cosine squared alpha out from the denominator. My motivation to do this is I want to have this. Okay, so what is left for me? So I took care of that one, but be careful about that. There is a discrepancy here. So what is left for me is sine alpha. Ah, by the way, sine beta, I can also take it out. That's a good motivation. I have sine beta here. Yes? So what is left for me here is sine alpha, sine beta. Yes?
Don't forget negative sign.
Thank you. Negative sign here. And then what is happening here now? Cosine beta, sine beta, no, sine beta is already gone, so plus cosine beta. But do you remember, I didn't have cosine squared. I took it out, so to compensate for that, I have to put cosine alpha. Yes or no? So you see, if I multiply this back here, this cosine squared alpha and that cosine will be cancelled, then I will have a cosine alpha in the denominator. Is that understandable? And then this probably is familiar for you. That's the formula of cosine alpha plus beta. Yes? This negative, it becomes cosine alpha plus beta. So this becomes cosine alpha plus beta. And that's exactly what we need. So I don't know. I think the mathematics was not that involved. Yes? It's more straightforward. So that's why I don't know. I'm not emphasizing that the mathematics is simpler. I would say that mathematics is simpler. First of all, you didn't encounter any tangents at all. And then this formula for our brain is easier because that is just the right-hand side of this formula. In the previous case, we have to be a little bit creative to read what will happen for that expression. Yes? So you see, by changing the coordinate system that I have chosen before, I was able to solve the problem a little bit easier. And sometimes this happens, it becomes a lot easier. So in principle, physics is independent of the coordinate system that you choose, but mathematics is not that independent. Yes? So it is always a good, wise decision to start with probably a better coordinate system. It makes mathematics a little bit easier. But my point of this question is, I want you to understand that if you change the coordinate system, still you can solve the problem. Yes, I want you to see what will be the differences. So actually, from physics point of view, it was a big difference, because in the previous case, the horizontal one is uniform motion. It is not accelerated at all. Only the vertical line is accelerated. But if I change the coordinate system, I will face two motions, both of them with constant accelerations. But still, if you really know what you are doing, you will get the correct answer. And that is very, very important if you want to understand physics. So it is very good to solve problems from different perspectives. And of course, it would be very, very challenging, and then you will see that the mathematics becomes so complicated. If I take just a random coordinate system like that, for example, yes, here, then I have to also consider the translation. So the initial positions are no longer 0. So in that case, if that is really here, and I have chosen this coordinate system, I have to consider, in these cases, I got rid of x node and everything, but here x node and y node are no longer 0. So I'm making life harder for myself. But if you are patient and do that, this should be the case that you will get the same answer. I don't know, is that understandable? Yes? So it is very important. If you write physics, physics is a vector equation. And do you remember when I was teaching you this course? In the beginning of this course, we didn't even talk about axes. We just started talking about vectors, adding vectors even without having the coordinate system, by this parallelogram law or whatever. And then we were able to multiply them, cross product them. And then from some point, I introduced you the analytic form of vectors. In that case, then I will have components. And the components are really sensitive to your choice. Yes? But the vector equations are independent. This is why vectors is a very natural language for physics. Because in physics, we do not have any coordinate system in the universe, yes? We do not have axes. We want to do physics without having a coordinate system. So this is why, more or less, all the equations in physics are expressed in terms of vectors. Yes? This means that if I can write an equation in terms of vectors, then I don't need to be concerned about addressing the coordinate system all the time. Yes? But if it comes to practical, and I want to solve it really and get a number, then I have to choose. Even because if you don't choose, it is sometimes possible, but mathematically it is much simpler to work with components, because then you can use algebra a lot. Otherwise, you have to think all the time geometrically. And I don't know how many of you have seen my video on this back cap rules from geometrical point of view. Sometimes I gave it. So if I want to prove the back cap rule, do you remember what was that? If you want to prove this, we had the formula used. Yeah, we had this one, back cap. Okay? So if you want to prove this, this is a vector equation. It means that it doesn't care at all where you have chosen the coordinate system. Yes? If you have seen my proof, it is that was really a challenge for me. That is why I was actually very interested to be able to prove it geometrically without using components. But if you want to use the components, it is not hard. It is a little bit lengthy, but not hard at all. You don't need to be creative at all. Why? Because you take some components for your vectors, A1, A2, A3, and then for B, for C the same, and then be patient and calculate the right-hand side according to the components, and do the left-hand side and compare. They become easy. They become equal if you don't make any mistakes. So proving this from algebraic point of view or analytic point of view is super simple. It's a little bit lengthy. But by the way, my geometrical proof was also very lengthy in that case. Yep. So I mean that at least you see that for proving things analytically, you don't need to be that creative, but for proving things geometrically, you have. This is why in physics, You always work with components rather than the vectors itself. But the equations are all expressed as vector equations. And that is very natural because the universe doesn't care about us if you have chosen the proper coordinate system or not. Independent of how we choose our coordinate system to solve the problem, physics shouldn't change. Yes? Then of course that would be a mess because depending to the observer, to the universe, you are doing some experiment here in Stockholm and then someone is doing it in New York, then you will get different things because you are choosing another coordinate system. So the physics shouldn't depend on the coordinate system that we choose. Okay, that's it. I want to stop here. And if you have any questions, please let me know. No questions? Yes?
Do you have some problem we can work on?
About these projectiles?
Yeah.
I can find one for you probably. Let me try to. So how much time is left? Not that much, but I will try. I will try to find it and post it, okay? If you want to, you can work on it. Thank you.